Today we're going to talk about basics of internet. Yes, we're talking about products and websites and apps all this while, but let's go deeper. Let's understand what constitutes internet, which has allowed the proliferation of websites and mobile apps and all sort of other innovations that have come all the way our way. So at the very basis of it, internet is a network of networks. It works very well even for 4 people network or a 4 billion people network. Okay. The way to see internet is it's a network of computers. The closest analogy I can give you is think of internet as something that connects the various homes that exist. Okay. Just like roads and flyways and highways and ships and airplanes, they all are methods to connect humans and move them from one place, that is one home, to another home. Similarly, internet is a network of roads and infrastructure which allows information to pass from one computer to another computer reliably. Okay. A lot of these analogies of roads and highways and flyways, as we go through this particular chapter, you realize that it works very well with internet. So just like postal service was responsible for sending information that in the form of an envelope or a courier or a box or a packet from one address to another address, similarly internet picks up information in the form of bits and bytes, which is packaged in the form of a packet. For the moment, just take my word for it, it's a packet that has to be passed from one computer to another computer. Just like as you're watching this video, essentially this video is hosted somewhere else, way like thousands of miles away from your actual computer, and your computer is getting this video in the form of multiple packets which you're watching as it goes along. So just like postal service was responsible for sending the envelope reliably from one place to another place, similarly, internet is responsible for sending information from one computer to the another computer. And this information is sent in the form of packets. Now, when you're sending something like in 70s when internet was developed, information was like few kilobytes or maybe few bytes actually, not even kilobytes. Now, information can range right from few kilobytes all the way to few terabytes, right? So obviously, you cannot send terabytes in one go. You have to break down the content, the information into small packets. These packets are usually uniform in nature. Because think of it um, as if the courier service or the postal service had just one size carton that they gave you to fill in whatever you want to fill in. So, for example, they just give you one form of an envelope that whatever information you want to send, you have to break it down. You have to reduce that down into smaller papers or sheets which you can insert in an envelope. That's all we can take. So, internet has something similar. You break it down into smaller packets, and these packets are then delivered to the destination, which could be another computer. Now, this sending and receiving of data is possible only because there are some standard protocols that were created. And at the essence of it, as you watch this video, you would realize the essence of it is internet is essentially just a design. It's a design of networks. It's not the infrastructure actually. It's more about the design principles or design protocols, which allow this communication to happen between computers reliably and in a fault tolerant way. That is, if something goes offline, if something stops working, the internet should still work. Okay. So this common language of communication between the two computers is called a TCP IP. Let me take a minute to explain what is TCP IP. Although we use TCP IP in the same breath, but they are actually two different concepts. Let me address the IP first. IP stands for Internet Protocol, but it's Internet Protocol Address. Okay, so IP is abbreviation of, or I should say, IP has become the colloquial form of IP address. What is the IP address? So just like all the homes have a unique address, that is how postal service discovers the address, and you have to write that address in a certain form, right? The street address, you have to put in the city, you have to put in the state, you have to put in uh, the pin code. That's how the postal service discovers your home, correct? Similarly, IP address is the unique address given to the final device at the edge of the internet. What is meant by the edge of the internet? Means a device that is uh, consuming the data, okay, or is consuming and processing the final data. This IP address is in the form of, you must have come across it in the form of, uh, it's basically just numbers. It's written in the form of, let's say, 274.123.53.83. That becomes a internet. That becomes an IP address. So when in 1970s, when this IP address was created, that this will be the final way to discover or detect where where the computer is. At that time, this IP address were designed thinking that, okay, when the internet actually scales up, it should be able to handle all the devices that want to get connected to internet at the same time. And at that time, 4 billion devices, that's billion with a B, 4 billion devices would be sufficient. So this form of IP address was created, right? So 274.183.83.53, right? That was sufficient at that time. But especially in the last a decade, actually past 2 decades, with the explosion of internet happening, this was discovered not to be sufficient. So this format was called IPv4 or IP version 4. So a new form of IP address has been created, which is IPv6. It's a much more longer um IP address, which is alphanumeric in nature. The IPv4 was just numeric, and that's why it had like 4 billion possibilities. Now, the new IPv6, and almost it's still under process, but almost all the devices are slowly uh, getting transforming into IPv6, and all the services are supporting IPv6. It's a multi-year long process. So the IPv6 is an alphanumeric code. It's much difficult to actually talk about. And the IPv6 contains 128 bits as compared to the first one, the IPv4, which had 32 bits. What does that mean? That means now more devices can connect, more devices can interact, and more devices can be working simultaneously uh, and connected to the internet. Now, let me just dial back to the packet theory, right? The transmission control protocol, right? Let me explain that. Now we have imagined that there's person A, there's person B with an IP address for each one of them. Now, person A wants to send a 4 MB file to person B. Now, 4 MB is not something that can be packaged into one single packet. So that's why the 4 MB file was, person A just clicks on a button that, hey, send this to person B. Fine. Now, this 4 MB file is automatically divided into small packets, which the internet can handle. These packets, you can imagine them to be in byte size or kilobyte size, okay? These packets are then delivered to person B via the internet. And internet actually, these protocols are designed in such way that they are responsible for sending the packets reliably to person B via the cheapest available route from person A to person B. Now, cheapest doesn't mean the cost, but it's the time taken to send the packet from point A to point B, the political unrest, the relationships between the different companies. For example, person A had, let's say, Verizon versus person B had like Xfinity, and what kind of relationship they enjoy, and basis that the packet will definitely reach, but it may take longer or shorter. Plus, during the communication, during the entire journey from point packet person B, A to person B, there might be scenarios where the internet is down for some of the zones or for some of the neighborhoods, right? So just like when you are commuting from point A to point B, depending on the traffic conditions, depending on the road blockage and stuff, you will take your own routes, right? You will change the route, you will reroute yourself, and you get to point B somehow. You may take longer, you may take shorter, but you'll get to point B. Similarly, internet is responsible for sending the packet from point A to point B reliably, and while doing so, it may reroute or route or whatever way possible to just get the packet A to packet B, person A to person B. Okay. Now I said 4 MB file was transferring from point A to point B. Now 4 MB file might be divided into, let's say for this argument's sake, let's say it's divided into 4,000 files, 4,000 packets. Now obviously 4,000 packets might not take the same route, because these 4,000 packets didn't go through the were not loaded, like to give you an idea, were not loaded into the trucks at the same time, right? So they were loaded into trucks at different point of time, and that small fraction of difference also can change the complete routing conditions or traffic conditions, and hence the different packets will reach point B, person B, at different times, and also completely out of order. Packet packet 1 might reach the last, and packet 43 might reach the first. It could be anything, it completely out of order, right? So when this 4 MB file into 4 divided into 4,000 packets has finally reached, when all the delivery, all the shipment is reached person B, at this point of time, TCP, which is Transmission Control Protocol, is responsible for taking a stock of whether all the files have reached me or not, or all the packets which constitute the original file have reached me or not. So it kind of takes a stock, puts them in the right sequence, and then delivers it to the person B. So person B wanted to just see an image, and just to see that image, this is all the background story, all the background stuff that happened. Person A clicked on a button, the file got disintegrated into smaller packets. These packets were routed via different routes, fit via different channels to person B. At person B, TCP checked whether the original file, all the components of all the original file have reached me, puts them in the right order, and then delivers it to the person B in whatever format, whether the person was trying to see it on Instagram, or whether it was an email, or whatever it was, right? Now, how does this happen? Like, how does this TCP knew that that what is the sequence? Number one, and number two, um, how did the internet know who to deliver it to? So when the packet was created, in a very simple term, the sequence was stamped on it. Number one, timestamp was stamped on it. And when I say stamped on it, what I mean here is, like in a physical world, you would have stamped like the stamps and all, right? But in the digital world, you would have created metadata, or you would have created attributes. In the attributes, you would have mentioned the from IP address and to IP address. You would have mentioned the sequence, and you would have mentioned the timestamp. So using this information, the internet is able to send the packet from point A to point B. And at the other end, TCP was able to use the timestamp and the sequence to put things together. Okay. So this is what TCP IP is. This is what internet is. This is what happens behind the scene. Okay. In the next slide, let me talk to you about a little more about IP, DNS, routers, and so on. Okay, some of this I've already covered in the previous slide. So I just want to take this moment to go through the ISP, DNS, and all that. So effectively, when we spoke about IP addresses, now IP addresses are just numbers, and they're horrible to remember, right? So just like you have mobile numbers, right? But who remembers mobile numbers anymore, right? What you remember is actually the person's name. and some more details about the person. If you have too many Johns on your in your contact book, you would like to remember John from company A, correct? And that's how you would like to dial that person. You don't care about whether the person what number this person holds, right? Similarly, when you're interacting on the internet between your friend or your company or wherever, you're not bothered about the IP addresses of your devices. You're bothered about which website I want to go to or which app I want to use, right? So your website would be, let's say, wikipedia.com or wikipedia.org or spotify.com, right? So when you're choosing to go this, so when you're doing this, when you're entering the URL, what you're essentially doing is you are trying to access the details of the server at which this URL is pointing to. Okay, let me repeat this. So when you're entering wikipedia.org, what really is happening is this wikipedia.org point is connected to an IP address. Okay, this IP address is of the server where all the files, images, HTML, all the text, everything that needs to be delivered to somebody who wants to check out this website is hosted. So server is nothing but a regular computer. Okay, except this regular computer has been optimized for serving data and not so much on processing data. There are obviously servers which are designed for all of this, but in for this discussion, you can assume that it's fair to assume that servers are just regular computers which are optimized for faster read and write. That is, they are able to accept a lot of requests from outside and they are able to send the information very fast. So this server, when it was hosted on some place, for example, you can convert your computer on as a server as well. It's not that difficult. So this server, which is hosting your all the files, all the images, all the HTML files, etc., a certain IP address was assigned to this. Now this IP address was then connected to a simple English URL like Wikipedia or Spotify or Pragmatic Leaders or whatsoever. This job of connecting these two things, which is IP addresses with the URLs, is the job served by DNS, which is domain name servers. So domain name is the URL. Okay, so it's a domain name server. So these guys are only responsible for essentially managing the mapping. When I say managing, they are basically, think of them as yellow books. That's it. They are internet phone directories. So they maintain the IP address and the domain that they point to in their directory. So when you're writing down URL, let's say wikipedia.org or let's say Spotify, what you're essentially doing is you're sending the browser sends the information to the DNS first. The DNS says, okay, this is Wikipedia. Okay, what's the IP? Then it starts looking for the IP address connected to this Wikipedia. It may have it, it may not have it, because understand, we are talking about 4 billion to 10 billion devices getting connected at the same time, roughly, right? So when such a huge number of devices connect, obviously one DNS cannot handle it. Effectively, it's end of the day, it's just a computer, right? So one DNS server or one computer cannot handle all the incoming requests or outgoing requests, right? So there are multiple DNS servers. Some of them are for different geographies. Some of them are for .coms, .org, .ins, and so on. Okay, so these DNS servers, let's say I am in San Francisco and I said Wikipedia. Now, the closest DNS to my location would be the browser would send the information to him saying that, hey, dude, Tarvinder wants to go to Wikipedia. Can you help me with that? DNS would say, okay, let me just look it up. DNS does a lookup, sees that okay, there's nobody matching, at least in his directory, there's nobody matching the IP address. Okay, DNS says just give me a second. DNS asks the other DNS server in his community that hey, anybody has any idea about where Wikipedia is? Maybe one person says that okay, let me just, like, have a look, and it discovers that okay, in his directory there's an IP address which is connected to Wikipedia, and it says yeah, this is good, I found it, and it passes it back to the original DNS which my browser requested. The original DNS said that okay, thank you so much. It notes down the IP address and Wikipedia and creates its own repository, or it adds it to its own database, and tells the browser that hey, this is the IP address. Browser says thank you so much, and browsers then points to the IP address directly, which then starts serving the data. That's how this entire thing works. Okay, browser to DNS, DNS then looks up and finds out which IP this domain corresponds to, and then sends back the information to browser, and then browser goes to that IP. Okay, so this is effectively how it works. And the ISPs that we have been talking about, the internet service providers, they're essentially just businesses which is trying to provide as much infrastructure as possible, so that they can keep the internet up and they can make more money off it. As simple as that. So this is all about how does the internet work. There is plenty of information available in the open world about how internet works. There are plenty of uh, videos all around, but these two videos should give you the uh, should give you a good idea about what's internet all about. Why do you need to know this? You need to know this because very soon when you start talking to developers and you start building a product, you need to know how these things work, because this basis will help you in understanding how APIs work. Okay, how get request, how post request, how HTTP, how HTML, and how all of these things work, how async and sync services work, right? You'll start to understand a lot of this once you understand this very basic stuff. Okay, so that's it for now, guys. Understand what is DNS, understand what's IP, TCP, understand how internet sends and gets the information, and understand how the IP address and IPv6 etc. works. Thank you so much. See you in the next one.